This file contains a photonic crystal cavity resonator, which is a slab with higher refractive index than the surrounding medium. The cavity is formed by etching a pattern of holes around the center of the cavity. Symmetry is used in the simulation region in the X and Y directions to reduce the memory requirements. For photonic crystal structures, the periodicity of the structure can be important, so it's important to make sure that the shape of each meshed hole is the same in each period of the patterning. So using an index monitor can be helpful to confirm that the mesh is set up with the correct mesh step size to achieve this. Add a refractive index monitor from the Monitor's drop-down menu. Edit the monitor using the Edit button or E keyboard shortcut. For the index monitor, since the number of frequency points recorded is 1 by default, you can see that the Override Global Monitor Settings is overwritten by default. Using one frequency point here is fine, since the structure that we're simulating is a dielectric material, which means that the refractive index doesn't change as a function of frequency. In the Geometry tab, the monitor type is 2D Z normal, which means we'll get the refractive index in the XY plane at a particular Z position. Set the size of the index monitor to match the size of the simulation region, which is 2.5 microns in the X and Y directions. And set the Z position to 0, which corresponds with the center position of the slab. Click OK to accept the settings. In the CAD viewports, you can see the yellow outline of the monitor. With the monitor selected, the available preview results are listed in the Result View window. Right-click to view the index preview. This doesn't support the automatic unfolding of the monitor data across symmetry boundaries, so you can see that we can only see 1/4 of the structure. From the color bar scale on the right, you can see that the slab has a refractive index of 2.65, and the etched holes have a refractive index of 1 as expected. We can also see that the shape of the etched holes in each period is the same, which is what we wanted to check. Now run the simulation, then plot the refractive index result. This result does apply the unfolding across the symmetry boundaries so that we can see the full refractive index cross-section. Now that we've seen an example of setting up the index monitor, here are some tips for using the monitor. You may find that if there are many small features of the structure, there can be some graphical artifacts in the plot, so it's best to zoom into the plot by using the Zoom mouse mode and clicking on or selecting a region of the plot to zoom into to clearly see the material interfaces of the structure. Index monitors may not accurately record material properties in regions using advanced nonlinear material models or grid attributes. You can use the nearest mesh cell interpolation option with the Record Conformal Mesh when possible option to see the effective index at material interfaces due to conformal meshing. You can only see this once the structure has been meshed after running the simulation, so you won't see this from the index preview. If you want to get this result without running the full simulation, you can use the Quit and Save button in the Job Manager after the meshing stage of the simulation has been completed and the simulation is in the running stage. The spatial interpolation options are advanced features, so we don't recommend changing these options unless directed by numerical staff.